In this video, we will investigate several more examples with the inverse trig functions. So the first of which is the limit, and then we'll move on to some integration. So we would like to determine what is the limit as we approach 1 from the left of arcsine. And really the maybe easiest and most efficient way to answer this question is to just visualize what the graph of arcsine looks like. So as we defined earlier, y equals the arcsine is a function whose domain is -1 to 1, i.e. the range of the sine function, and the range of arcsine corresponds to that restricted domain we had for sine. So that would be minus pi over 2 to pi over 2. So roughly speaking, we can say we're going from -1 to 1 for our inputs, and then in terms of the outputs, minus pi over 2 to pi over 2. And graphically, arcsine looks something along those lines. So in terms of the limit as we approach 1 from the left, we're thinking if we plug in an input close to 1 on the left, what are those outputs going to be close to? And the answer is pi over 2. So the value of this limit is pi over 2. Similarly, if we were asked the limit as we approach -1 from the right, we'd say -1 from the right, those outputs would be minus pi over 2. So let's evaluate the definite integral. And as a reminder, looking at the form here, 1 over 1 plus x squared has the antiderivative of arctangent plus a constant. So for us, we can think of pulling out 8, and what remains is the antiderivative of 1 over 1 plus x squared, so arctangent. And we're evaluating here from 1 over root 3 to root 3. So we replace the x with square root 3. Put a minus sign, and we replace the x with 1 over the square root of 3. And both square root 3 and 1 over square root 3 are kind of common values for us to evaluate the arctangent at. Arctangent of square root 3 is equal to pi over 3, because let me just note below, the tangent of pi over 3 is equal to root 3. Similarly, arctangent of 1 over root 3 is pi over 6, because the tangent of pi over 6 is 1 over the square root of 3. So it is most definitely beneficial to know the common values of the trig functions. So pi over 3 minus pi over 6 is pi over 6. So 8 times pi over 6 gives us 4 pi over 3.